Okay, we are looking at z-scores. What do z-scores do? Z-scores tell you how many standard deviations of a data point is from the mean. So how many standard deviations is a data point from the mean? So we have a population z-score, which is just x minus mu over r. And as you can see here, sample z-score is pretty much the same. It's the data point. Take away x bar, which is just the mean, right? I have the mean here, and I have standard deviation, and here is also standard deviation. It's just different notation. So it's actually the exact same calculation, and this is the data point. Data point. Data point. And it's telling me how many, if I have a point, right? I have a point, I have a distribution. This is the mean right here. This is mu, or x bar. And I have this point right there, right? It's asking me, this is the standard deviation right here. Z-score will tell me, for this point, how many standard deviations am I from the mean? So essentially, this is like 1.5. If this is a standard deviation, it's like how many, if standard deviation is a measure of distance, how far is this point? How many in standard deviations from the mean? Well, this is like 1.5 standard deviations from the mean, as an example. So that's what z-score means, and this is the formula for calculating it. Okay? It's pretty much the same calculation, different notation if you're talking about population versus sample. So here's an example. A car manufacturer tested the gap between the doors of the body of a car. 18 samples were taken. Their gaps in millimeters are shown. Okay, so here are the gaps. So determine the sample mean and the standard deviation. So the sample mean. So we have to use one of our formulas. Calculate the z-score of a door with a gap of 1.6 millimeters. Interpret its meaning. So 1.6. So first of all, we have to calculate this mean and standard deviation to get that. Then calculate the z-score of the door with 1.4. Compare its distance from the mean to that of 1.6. Okay, so what's closer to the average, 1.4 or 1.6? That's what it's asking. The manufacturer rejects any cars with door gaps that are not within 2 standard deviations of the mean. Which car should be rejected? Okay, so our first step is to calculate our standard mean and our sample mean and our standard deviation. So our sample mean, we add up all our values. Okay, you do this yourself with a calculator. And you take every single one of these values and you divide it by the number of data points. And that's equal to 27.6 divided by 18. We end up getting a sample mean of 1.53. So on average, the gap in millimeters for the doors of the body of the cars for the samples is 1.53. So now that we have our mean, we have to see each point. How far away is 1.53 away from 1.7? How far away is 1.9 from 1.53? So some of them will be below, half of them, give or take. Some of them will be below 1.53, and some of them will be above 1.53. But on average, they'll all be 1.53 millimeters. Sorry, we'll have an average gap of 1.53 millimeters. Okay, so now that we have the mean, we have to calculate our standard deviation. So we take each point 1.7, 1.7, 1.9, 1.9, 1.4, 1.4, 1.4 again, etc. 1.5, 1.5, 1.7, 1.7. Subtract the mean from that, square it, and divide by n minus 1. Okay, so we take all our points. Oh, I highlighted it. So 1.9, right? They all correspond. Each value, we're going to take it, subtract the mean from it. We're going to square it, and then we're going to divide by n minus 1. Each point. Okay, step by step. Okay, so you can do these calculations yourself. You end up getting 0.67 squared for the first point, etc., etc. Now it's just a matter of computation. Sometimes it's better to use a table where you go step by step. So the first thing I'm going to do is I'll put my points, xi, and I'll put all my points, 1.7, 1.9. Then I can do xi minus x bar, right? And that would be 1.7 minus 1.53, right? 1.9, 1.4, 1.9 minus 1.53, 1.9 minus 1.53, right? Then I can do x minus, and that would be equal to 167, 0.6367 minus 0.133. Then I can do xi, minus x bar, for all of them, by the way, keep going. Xi minus x bar squared. So then we square it, right? And then we do 0.167 squared. And we continue for all of them. And then we can add up all our values. Okay? And then divide by 17. But that's one approach. Okay? Or you could do it out like this. I recommend doing this table, but I just wanted to show you mathematically how it worked. So essentially, when you do your math, you're going to end up getting a variance of 0.048 and a standard deviation of 0.22. So that's our sample mean and our standard deviation. Our sample mean is that, and our sample deviation. So calculate the z-score of a door with a gap of 1.6 millimeters. So it's all of these doors right here. What's the z-score of these? How many standard deviations is 1.6, right? If that's my data, I have 1.53 is my x bar. That's my mean. 0.22. That is 1.75. So where is 1.6? 1.6 is going to be around right there. So how many standard deviations is it? That's one standard deviation. So it's going to be less than one standard deviation from the mean. But we can use our calculation. X, our data point, minus our mean, divided by the standard deviation. We end up getting 0.32. And as you can see, right, it's less than one standard deviation from the mean. So that's the z-score. What about 1.4? Well, 1.4 is the same thing, right? We have, that's not right. Let's fix that again. So our mean is here, 1.53. We have minus 22. So our standard deviation is 0.22. So that makes this point right here 1.31. So how many standard deviations is 1.4 from the mean? It's also less than 1. When we calculate the z-score, is 0.6. And exactly that's what this is saying. How many z-scores is this from the mean? And sorry, how many standard deviations is this value of 1.4 from the mean? And the answer is 0.6 deviations from the mean. So the manufacturer rejects any car with door gaps that are not within 2 standard deviations of the mean. Which cars would be rejected? So if I have a standard deviation of that, if I have a standard deviation of 0.22 and a mean of that, what's the point over here? So I calculate for x, I multiply 0.22 by 2, we get that. And then we move this to that side, so we add it, 1.97. Cars with a gap more than 1.97 millimeters would be rejected. So what would be rejected? Car gaps with less than 1.09 would be rejected as well. So what does that mean? Okay, so another way to do it, I don't really like this method. Another way we can say is we have a mean of, let's draw it out just to explain. The mean is 1.53. This one is 0.22 right there from here to here. So that makes this 1.75. That's one standard deviation. 2 standard deviations from the mean is, 2 standard deviations from the mean means add another plus 0.22, add another 0.95, 97. That's where we got that. 1 standard deviation from the mean on this side, we calculated earlier, subtract 0.22, we get 1.31, right? And then another standard deviation from the mean, we get 1.09, right? That's where I got this number. So anything less than that, rejection zone. Reject. Reject. So which ones would be rejected? Not this. Anything greater than 1.9? No. So nothing would be rejected. Anything less than 1.1? No. Any 1.0s? No, so nothing would be rejected. Okay, so we graphed it there properly. This is what I just drew. That's 0.22, 1 standard deviation from the mean. Right? So a z-score of 1. Anything over here is a z-score of 1. Okay? But anything over here, let's draw that. Anything over here would have a z-score of 2. So nothing is outside of 2 standard deviations from the mean, so nothing gets rejected. All right, here's your homework. This was already assigned yesterday. I forgot what we wrote here, but it's in the Google Notes. So that's it. Thank you. Bye.